So you see me winding down Russ at about 20 after 3. We have plenty of time today because we didn't have a lot of show and tell, so I don't think it'll be a problem, but just so you know. There you go, Russ. Get the light out?
Yeah, one of them. Okay, so first couple of things. Satellites for amateur radio use and experimental use don't look like that anymore. But it was available, so I threw it in there. So there's sort of a prevailing theme to this presentation, and that's that for $50 you can get involved in what's really active now and hot in satellite communication. Or you can spend $5,000 and do the rest of it. Or I should say an additional $5,000 on top of anything else you've already spent. So the problem that you'll see in the presentation is that the voice satellites that AMSAT and other organizations around the world put up years ago, early in the 2000s, late 90s, have all, gone out of service in the meantime. So what we've got left is a late start resurgence of shooting satellites up there again. And it's taking some time to get back to, I don't know that it'll ever get back to where it was, but it's taking some time to get the hobby for amateur use, amateur radio use, started back up again. And AMSAT's had some tough financial challenges and just some other things that have been going on. Okay, but
Space bar.
mm-hmm.
Hit the space bar.
Yeah, might have.
Page down. There we
There you
go.
go.
Hey!
Hey! Working with 1990s computer technology. All right. So, satellite as part of our hobby just opens up yet another thing to play around with in amateur radio. So, I got into it primarily because I was looking at VHF, UHF weak signal about a year ago, and then planning ahead to go on my roof, in the warm weather, certainly not now, and what I was going to put up in the summer. And, well, that kind of fell through because I found out in making connections with people through the Northern Light Society just how infrequent weak signal really is. Satellite's 10 times as more active than weak signal, which is not very active at all, I'm afraid. So while there have been some people that have worked all the grids in the country in weak signal, UHF, VHF, that's kind of, that was really tough. Took 10, 15 years to complete anyway, but nowadays just couldn't even be done really realistically anymore, not unless you're going to do it over your entire lifetime, really. And that's with the help of rovers and everything else. The thing that satellite offers, though, is they come to you, so to speak, right? So they're flying over our heads all the time, and really, as you'll see somewhat graphically, there are a lot of opportunities to do things with satellites, but mostly on the receive side of things, mostly on the telemetry and reception side, which I'll talk about. You can work the voice modes. The predominant voice mode is FM, as I said earlier, more so than weak signal. There is sideband on satellites, but very, very rare that that can be worked. And there's only 2 satellites now that have linear transponders that are active up there that allow you to work sideband anyway. So most of the satellites today that you can work are just going to be on FM. The vast majority of them up in the air that are active, like 99.9% of them are going to be receive-only kinds of things. So I'll talk about that. That kind of sits on the periphery of our hobby, but it's certainly a part of it as well. The requirements to get started are pretty minimal. You need a PC like you do with digital modes, but most of us are using PCs for logging software or remote tuning or what have you, so that's not a big one. Most of the software is free or has a free operating mode, or it's shareware with Donate or what have you. So very inexpensive on the software side. Most of it, again, is free. You need a rig of some sort. Now, if you're going to do regular VHF, UHF, uplink, downlink, voice, then a standard handy-talkie, dual-band handy-talkie is good enough. If you go back in some of the online information about satellite operation, which is a bit dated now, they'll talk about running full duplex rigs, and they'll talk about all the antennas and the rotors that do both azimuth and elevation, and having that rotor control through Ham Radio Deluxe or some other software package. But as I found out quickly, and fortunately before I spent any money, that's really not going to buy you a whole lot of satisfaction, so to speak, from that part of the hobby, because there's just not a lot of operations going on. If it were busy like it was 20 years ago, or busier like it was 20 years ago, then that would be a different story. I better hit woke up. So you'll need an antenna or two. Mostly that's a statement about if you're going to have a base station set up. If you're going to run portable with a handy-talkie in your backyard, for example, or at a field day event, there are portable antennas, which I'll show here, that allow you to operate satellite when someone's there to talk to quite easily. Pretty much covered that. So what's happening now that's part of the revolution, or making a comeback, is the telemetry and data side of things. In the experimental, university institution, and private sector, there are a lot of satellites that have been launched here in the last couple of years and will be launched in the next 2 years, the CubeSat variety, which we'll see in a minute. But there are many more opportunities to receive telemetry and data from experiments up there than there are to have a QSO. That's just the realities of it. Once AMSAT gets Fox 1 and Fox 2 up, which I'll show you here in a minute what's going on with that, then that might change. All right, we've got some new amateurs in the hobby. The last few years, a resurgence with the maker movement and such, and people in the maker movement are starting to gravitate more towards amateur radio as a result of that, just to broaden their horizons as well. So we may see somewhat of a resurgence on the voice side of things. But so the satellites that are up there that are of interest to us, whether it's for a QSO or for just receiving, are all in low Earth orbit. And the way that works is we have geosynchronous orbits for satellites that are broadcasting like DirecTV, that need to be on the near the equator and staying with the Earth as it rotates, so that you have a constant signal and they don't have to put up satellites or a limited number of satellites. The low Earth orbit satellites are up between 350 and 500 miles above the ground, up, and they're in a polar orbit, not directly over the poles, typically at an inclination one way or the other. So they're all spinning around the Earth at anywhere from 0 to about 70 degrees inclination around the poles. What that does is it provides some satellite coverage, again, reception or for having a QSO, pretty much 24/7, with some gaps in between, of course. But there's always something flying overhead of interest pretty much all the time. There are literally hundreds of active satellites that you can receive in the VHF, UHF spectrum. There's a few left operational. The main one is FO29, which is a Belgian satellite that has a VHF 144 uplink and a 29 megahertz 10 meter downlink. Those are becoming pretty rare now. The working satellite FM on 10 meters. The visibility, which is essentially like drawing a circle or an oval over some part of the face of the planet, where within that circle or oval is the ability to communicate, or at least to receive information from that satellite. That visibility for a given point on the map, like the Twin Cities, for a QSO at least, will typically last 6 to 8 minutes. Sometimes a little less, sometimes a little more. Depends on the speed of the satellite, and it also depends on how far away it is. If it's directly overhead, or nearly directly overhead, you'll get some length out of it. If it's going to be any distance at all, either to the east or west coming over Canada, then that period of time, that visibility is really going to work for you, is going to shrink, sometimes down to 3 or 4 minutes. Because the satellites are traveling at such a high rate of speed, so give you a feel for this, a typical satellite like Funcube, which recently launched, that was launched and put up into operation at the end of November and essentially turned over for public use at the beginning of December. That type of satellite will move from Russia over the pole into our space in about 10 minutes. Okay. So basically, as you're tracking that satellite and you're setting up for a particular pass that's going to be close being this side of Wisconsin or the other side of Minnesota, let's say from a visibility standpoint, from a line coming down north to south. There isn't a lot of time once it's out of the Indian Ocean and coming up through Asia and coming over the pole. You got about 10 or 15 minutes to have everything ready at that point. That also makes it a little interesting on QSOs, because that's a matter of being in the right place at the right time, and where there's operations that are pre-scheduled, it's not so much of a problem. Or if there's some kind of event going on, there's not so much of a problem because there's a lot more activity. When there's not, there's a lot of dead air, and you really don't hear much. You know, I'd be lying if I told you otherwise. So, although you can talk to yourself if you run Duplex, you can run your uplink and then hear your downlink coming down, which is nice. But you won't. You'll call CQ and the equivalent of calling CQ on satellite, and really won't likely hear somebody come back.
So, do you ever answer yourself?
No.
Send him
Not
a
yet.
card.
Yeah.
Not yet.
You are himself.
So I skipped over the Doppler effect a little bit, but basically, because these satellites are going so fast, as they're coming over Canada and heading towards Minnesota, then the downlinks tend to be in the UHF range. The signal's going to get compressed a bit. Okay, so the frequency of operation is going to go up 10 or 20 kcs as it's coming in, and then you have to come down with that, come down to the frequency of operation, and then as it's moving over Minnesota and heading down through the central U.S., then come down a little further because, of course, that spectrum, that electromagnetic wave is getting stretched a bit, effectively, because of the Doppler effect. That isn't as complicated as it might sound. Even without software help, if you're working portable in the backyard, in the summertime probably, with a satellite, you as the rotor, right, have ultimate flexibility in terms of just hearing the signal strength and tuning that way. And also as far as having all the hundreds of channel memories in these handhelds nowadays, you can simply click and then have it go through. And that's the recommended practice. Set up your 5, 20 kc, plus 20 kc, plus 10 kc, 0, minus 10, minus 20 in 5 successive memory slots, and then just hit a button. Whatever button will walk you through that, or dial will rotate you through that. So it's very simple to do that, and not a big deal. You really have about a minute or so per 10 kc bump that you're going to make. So it's not difficult to do.
Russ,
Yeah.
if I might add, what I tend to do that worked for me is I keep the transmitter on the same frequency.
Right.
And then if it's coming up from over here and going overhead, I would set it higher, like 20K higher, and then see, and if I got locked in with the FM, then I would, be able to hear people, and then it would start to fade out, and I just flip it another 5, just turn the tuning knob, and then it would come back in, and then when the satellite was overhead, it would be about right on frequency, and then I would start going down as it was heading off this way.
Right.
And I had a little iPhone app that would show you exactly where the satellite was, where you are, so you can see, if you're, where you are in the path as it goes by.
Right. Yeah. We're going to talk about software in a little bit, but that kind of application installed that you can have with you is really handy when you're outside, obviously, working portable, and not necessarily having direct internet access. Okay, so the recommendation, again kind of dated, is that it would be best to have full duplex mode so you can hear your own downlink. That way, the adjustments, if you're doing the manual, the frequency adjustments are then, of course, a lot easier. You can hear the other part, you can hear yourself, and so it gets a little bit easier. Of course, there's software that will do it for you. It will adjust using the Keplerian elements that you're going to load in once a week or so. And it will make all those tuning and rotational and azimuth adjustments in the $5,000 big station situation, right? But that's where you sort of cross from maybe ham radio as a technical hobby into operating maybe a little bit more, because at that point everything gets automatic, right? Much like contest stations that, are big dollar contest stations that do pretty well. So it's very common for people to use dual band handy talkies. My original handy talkie from China actually had a final go out on it, so I used that one for the downlink, and I used my new one, my Yaesu, for the uplink. Okay, so that's full duplex, just simply because I've got the antenna split and have 2 handy talkies to use with that. After I found out that going and investing in one of the Yaesu rigs, mobile rigs that would do full duplex, that was a great move on my part to save a few $100s, because it really, again, because of the amount of traffic and activity that you have, it would be a nicety, but unless you're going to use that same rig in your mobile, for regular FM repeater operation, why spend it? So The handheld arrow antennas are really popular for the FM communications, and of course can be used on your base station as well if you want to put it up, in the winter, let's say, and take it down and use it portable in the warmer months. There are people that do that all the time. They're not a lot of elements. Typically, the arrows are 7 elements on UHF, 3 elements on VHF. And the main reason for that is directivity in satellite ops can work against you because your beam width gets to be so narrow that tracking becomes difficult, and you almost need software to do it for you with an azimuth elevation rotor. If you get too much gain, stack the antennas and basically narrow the beam width down a lot. And in fact, one company, M Squared, offers dual omnidirectional antennas that look like egg beaters, basically, that sit there, and that's a great option. Except I seem to recall that that antenna's or that set's about 500, so it's a bit on the expensive side to have something that you don't need a rotor and don't have to worry about elevation on. But it is available. Omnidirectional antennas will work. And as I said, weak signal is pretty much gone by the wayside for the most part, except for contests, when you have the VHF and UHF contests. All right, so as far as finding satellites goes, there are software packages that do this, but I just found this great website, N2YO, that has real-time tracking information. You don't have to load in the Keplerian elements to do the math behind the scenes. That's all done automatically on the site, and that allows you to see where the satellite is and get prepped. The other thing that is out there is SAT-PC32, which has been around for a number of years, and the thing that program adds is that it will also do the frequency shifts, the Doppler shifts, and drive a rotor if you happen to have one. But that'll do the frequency shifts, and that's kind of the main thing. Again, once you get into understanding what's going on and just listen a little bit at first. In fact, there's a few YouTube videos, one that I've linked at the end of the resources page, that if you watch, you'll get the gist of it right away. Just what Roy was mentioning and what I've already mentioned, that down tuning as the satellite passes is really not a hard thing. This will also give you, the site's a great resource for finding out information about what satellites are active, other resources, different kinds of satellites like educational, governmental, commercial, amateur. So he's broken it up into different lists. And it also gives you past predictions so that you can see in the coming 5 days which passes are going to come overhead that are going to be in view. He actually shows what's in view, what's not. So therefore, you might have, say, 8 of them that are listed, and then only 2 of them that are really going to be workable for your location, because you enter in your geo coordinates into the website. It remembers them, it caches them, in fact, and then every time you go back, when you do past predictions, then it knows exactly where you're at versus where the satellite's at. Yeah.
So as far as like thinking of the conservation of momentum, where angular momentum, where the satellite will orbit in the same plane throughout the year.
Yeah, right.
Is it something where, I came by to the east of you yesterday, so it should be overhead today, sort of thing?
Well, yeah, except the thing that messes it up, and the reason that there's Keplerian elements, is because of 2 things, really. Time differences that accrue over a longer period of time as we're going around the sun, and then the wobble of the Earth around its axis, right? Where that wobble is and where you're at, because you're on the Earth, versus that fixed orbit, right? Even though it's constantly in motion, takes a little bit of math. Now, all that really means is that if you watch a particular satellite, like Funcube, a new one like that, and it comes over about where still water is, let's say, within 90 degrees, right, overhead of still water. Then the next time it makes a pass that comes close to that, it might be in Maplewood, right? Because there's going to be a little bit of skewing because of the precession effects, right? The physicists back there could tell us more about that, but I'm trying to bullshit my way through it.
Not me.
Well, the other part is it's a 90-minute orbit. So if the first orbit in your area is like low on the eastern horizon, the next one's going to be, 90 minutes away. So the Earth
Right.
has moved for 90 minutes. The satellite's in the same spot,
Right.
but the Earth rotated 90 minutes under it. So now it's going to be a little bit, farther to the west, maybe even overhead, depending where the first one was. But the elements are needed because of all the, like you said, the various effects on it, including, some minor atmospheric effects, even at that altitude.
Right.
So
Yeah.
if you want to be accurate within a few degrees, you need to have that. Generally, they try to update them, every week or two. If it's more than 10 days out, they suggest that the software suggests that you need updated.
Right. So it's accounting for errors, basically, small errors that may or may not make a difference. But certainly if you were on in September and then you decided to get back on in February, then you've got to update those, because then things have skewed a lot in those months. Thanks, Rick. Okay, so voice operations, as I alluded to, is pretty much like using a repeater that's in the sky. Some of the transponders have to be activated, so you hit them with a tone, but you hit them once. Instead of a repeater where you've got that sub-audio tone every time you're keying up to unlock the repeater to let you through, satellites have to be activated. Now, if there's enough activity, somebody else has done it. You don't necessarily have to turn it on, but for power conservation, because these are all running on batteries with solar power, and in the milliwatt, tens of hundreds of milliwatt range on their transmitters. Not talking about a lot of power here. So, and especially with the CubeSats, which are about 4 inches on a side, just not a lot of power in that package. So they have to conserve that. And so what they'll do is they'll shut off within a fairly short period of time if there's no activity. So oftentimes as the satellite's coming in, becoming visible, it's off. Because why? Well, because no one in Canada north of us has turned it on, basically. We might be the first opportunity to hit that satellite and activate it. Typically, that's a 67 hertz tone. It's not as all over the map as repeaters are, so 67's used quite a bit, but not all of them are tone activated. Some of them are activated purely on the presence of RF. So it depends. I think some of it depends on how old the satellites are, but either way, it's a one-shot kind of a deal. Okay. You have any comments on that?
Well, I just add
From
that
experience?
at one point there were 2 satellites up that had the same 145, 850.
Yep.
So
Yep, still
that
are.
one of them required that activation code.
Right. Just for the chances when very few times they're within the same visibility at the same time, right? That's a good point. So as I said earlier, most people start working these easy sats. There's a Saudi sat. There's an American one, AO27, which right now is being rebooted daily to try to fix a software problem. So it's essentially down right now, but they're working on trying to get the software bug out. AO73, which is the number that was assigned to Funcube 1, which, as I said, became active early December. And then Fox 1 and Fox 2. Fox 1 is next November, and Fox 2 sometime in 2015. There's not a launch date scheduled for that yet, but they are on a specific payload for the November launch for Fox 1. And those, again, are voice, data, and digital mode satellites, plus some telemetry just for interest purposes. There's a picture of AO27. That's not quite a 1U satellite, that's like 2 units on edge, which would be about 8 by 8. The Fox 1 that's going up in November is a 1 unit or 4 by 4 by 4 CubeSat. So these things are pretty small sitting up there in the sky.
This will hurt when you hit you.
All right, so the Earth isn't flat, obviously, so we've got this curvature, and the satellite's coming in, and because of the angle at which it may be slicing across the U.S., especially, the visibility gets affected by that, and this 100-mile thing is just observational thing. If you do the complex trigonometry to figure out how close a satellite would have to be by line of sight, it's not going to be 100 miles away line of sight. It's going to be much further away than that. And if you do it from a distance standpoint, thinking about what elevation you have to operate that satellite at. So in other words, a 10 or 15 degree elevation low on the horizon means that satellite's pretty far away. And at 90 or near 90 degree elevation means it's pretty much going straight overhead, all right? Obviously, the ones that are going straight overhead at about 350 or 400 miles is actually closer line of sight than the one at a 15 degree elevation. But what I've noticed is that, as I said earlier, is that if a satellite's going to cross into western Wisconsin or western to our east or western Minnesota to our west, then it's visible from the standpoint of being able to communicate, receive telemetry, whatnot. Any further away than that gets a little bit iffy. Has your experience been similar?
I agree with that. And I usually looked at the circle of, where
Right.
the footprint of where the satellites see,
Right.
on the Earth. And then I would say if it was above 20 degrees, I might have a chance,
Right.
of working it for a few minutes, because it's only going to be very, like the sun in winter, just up and down.
Right.
Above 20 degrees, I'd have a better chance.
Yeah, that's
I
true.
usually set my software to don't even tell me unless it's above 20 degrees.
Right.
Quick question on Doppler. You're saying you leave your transmit frequency set solid, so
Yeah.
you don't pair them up, and as you put through memories, change your transmit frequency at the same time?
No, the way it works is as a transponder, it comes in and then out on the set frequency. If
And
you
they
change your
adjust for Doppler.
transmitter,
The newer ones adjust
Yeah.
for Doppler coming
Yeah.
in.
yeah.
So Roy's right. You often don't have to adjust on the transmit side,
Right.
only on the downlink or receive side.
Right.
But it depends on the satellite.
Because it's just turning over, what you had and what it received, and as it's coming towards you, that frequency 437, whatever, is now slightly higher. So you just set your receiver, a few kilohertz higher, and see if you pick it up, and then if you don't, you twist it a little more, and then all of a sudden, it gets quiet, and then you hear voices, as the FM.
Yeah, what the guys with a lot of experience will say is that on the newer satellites, if you stay on the uplink frequency and you're listening to your downlink as you're adjusting for the Doppler effect, you don't detect any change, which is a little counterintuitive because the older information said you had to adjust both transmit and receive.
Yeah.
But what you find out is that they're adjusting it on the transponder automatically, all right, so we don't have to, which is a little screwy. I don't know how the software packages have handled it, if they differentiate or not by satellite. They probably must, but that's something that's been a more recent development.
Does the change in frequency at 2 meters, it's not the same as it is at...
No, not at all.
Right.
No,
It
not at all.
follows the Earth.
That's why the uplink is 2 meters, and
Oh, that's, I see.
and you
Yeah.
just leave it.
Because you'll get a 2.5 to 5 kC shift
Yeah.
Oh,
on the
okay.
Doppler, right?
Right.
So they don't have to slide as far. So good question.
Mhm.
They're really not adjusting as much anyway as you are on the UHF downlink. Okay. Now it can be the other way around with a UHF uplink and a VHF downlink, but that's not really the norm. I mean, some satellites do it that way, but VHF up, UHF down is more common.
And I think the way that transponder is that, you know, it's set to a certain frequency, but it has this wide band.
Yeah,
You know, that
that's
takes
true.
into
anyway.
account
Yeah.
that it's Doppler coming into it as it comes
Right.
towards you.
Because if you run 20 kc FM, for example, wideband, and we're transmitting, 5 or 10 narrow band, then, there's some slop in there anyway. Okay, weak signal beat to death. Telemetry information, or the availability of telemetry information, if you think back to the NASA days, being able to monitor things from the moon shots or the space shuttle or now the International Space Station was more difficult, back in the day. And it's gotten much, much easier. It's become more open, more published, and in fact, with Funcube, as we'll see, they even provide the software a lot of times to get the telemetry, do the decoding, and display everything in a dashboard for you. So what could be easier? There are going to be and are additional satellites launching because of public funding through sites like Kickstarter. So you have this crowdfunding idea where people will say, I want to put a satellite up and I'm going to run experiments, or you can program the micro in there to run your own experiments because I put an Arduino in this satellite, and you can upload code to it and run and do some things with the sensors that are in the satellite. There's been a few Kickstarter projects like that. And then they have to hitch a ride. So their big problem, if you will, or challenge is not so much the cost of building a satellite, because they're really not trying to build a satellite for a very long period of time of use like AMSAT is. They're not, worried about that so much, or the effects of radiation or other things. They're makers, right? So what they're really trying to do is get enough money to hitch a ride on one of these orbital launches where they're going to put up a set of these CubeSats, like the Dove system, or the new CAT system, or the HyperX as a payload, which is a lot cheaper than if you go on a ride on SpaceX or HyperX, well, not SpaceX, as a passenger to go into low Earth orbit. They're getting discounts on these things, and essentially, like a toaster, they have to, at the right point, pop these things out as that trip is being made. And that's actually how Funcube got launched. It was just ejected with a spring, basically, along with, I think, 7 other sats, if I remember correctly. And now this CAT system, which I've got a link to in the back, is something that's being worked on at Michigan State, where they've got an ion propulsion motor that's not powerful, but for a CubeSat, doesn't have to be. So you need just enough in 0G to go and get that thing moving so that you can actually get that deployed out there, maybe from a lower Earth orbit, and slowly make its way up to 350 miles. There's a big advantage to that because, as you remember from high school science, all the energy is to get up there at escape velocity and get up into the atmosphere. So, and that's where most of the money is really, and the fuel cost and stuff. So if you can get a satellite partway there and then have it take itself the rest of the way, that's a pretty big deal from a cost saving standpoint. So there's a lot of buzz about this CAT project because of the ability perhaps to get these satellites launched quicker and launched from lower orbits, lower relative orbits, than having to shoot up something like the European Space Agency does with their satellite launches, or something like the military does with their satellite launches. Those are big, expensive undertakings, of course. So I mentioned Funcube, MASat, KickSat, which is an interesting project that got funded on Kickstarter, I think last September, where they're actually going to put up something like a CubeSat, but it's actually got an ejection mechanism, and it can launch out 8 sprites. And what the sprites are is circuit cards. So essentially, they're looking at putting circuit cards into orbit and acting as these little satellites to even scale it further down from CubeSats. Again, if you don't care about it being up there for more than a year or so, cheap is really what you're looking at. So you're not looking at longevity, you're really looking at cost, right? And so they raised, I may have the numbers backwards here, but they raised something like $96,000, which gave them the ability to get this thing on a launch vehicle of some kind and get it done. Same thing with SkyCube, which is kind of humorous because it's basically a text message application running on an Android phone where you can send up your personal message if you participate in the Kickstarter, and then it will beacon it down. Basically text the earth, whatever you want to say kind of thing, right? Yeah, right. So, the reason, I gotta wrap up here, but the reason that I brought this in is this is a DVD dongle, the Funcube dongle, which goes for about $99 roughly US. It's a very similar looking thing, but these are $20 out of China, okay? They're for digital video broadcast mode. And so if you buy one of these, you'll get software where if you hook up a digital TV antenna, you can actually watch TV on your PC, right? But it turns out that the chip that's in here, along with the VCO, covers from about 100 megahertz all the way up to, well, even lower than 100. I think 50 megahertz all the way up to 900 or 1.2 gigahertz, depending on what chip is in here. So you have a very wide range software-defined radio here in these, and SDR Sharp, which is the one that works really the best with these, is a program that's free. And SDR Sharp then takes the I and Q signals that come out of this and then demodulates it so that you get your audio, and then that DSP processing is happening through your audio cables coming into your PC, just like in digital modes. So this covers everything from the low end of the FM band all the way up into microwave, essentially. As I was saying to Jeremy earlier, it doesn't have a lot of dynamic range, but it has to cover a 3 megahertz slice. So in SDR, oftentimes you're covering 44, 48 KC, 96 KC, whatever. This has got to cover 3 because it's going up in high frequency range, and to be able to cover a usable spectrum with SDR, you need to have some bandwidth to be able to move that window. And 44 kilohertz wouldn't cut it very well at UHF frequencies especially. So I've used this for decoding Funcube telemetry data. And the Funcube dashboard actually allows, does everything for you. All you need is some way to get the audio in. Okay, and that's what SDR Sharp in this little dongle, which just plugs into a USB port, by the way, on the side of your computer. That's what it's for. So once you've got the audio from the beacon that's coming down, which is, in this case, BPSK, so it's just like running PSK 31, technically speaking, land-based. And then the dashboard will fill in all the data as it's receiving those packets down coming in. So it's kind of cool. It's not something you're going to do a lot of. There's a data warehouse that goes with this. So when it gets the data that you've received, it actually transmits it to the master data warehouse. So you're contributing to the monitoring and statistical data that they're keeping with it. So it's not for nothing, really, but it's a little boring in the sense that you get to see things like the power amplifier is okay, the voltages are okay. Oh, it's minus 54 degrees centigrade inside the thing or whatever. It's interesting, but unfortunately this doesn't do anything for you general purpose. So that's kind of the challenge with some of this telemetry stuff is once you've received it, you've got this audio signal with these packets coming in, then you need some kind of software to decode that. And usually it's not so much proprietary, but it's a little bit different for each application out there. So if you're trying to get experimental data that's being sent down by a NOAA satellite or something like that, typically you go to the NOAA site, download the software, and then you're in business. Well, as I said earlier, until Fox 1 and 2 are up, we're really going to be short on voice data satellite or voice digital mode type satellites. And in particular, and Roy, please chime in again. The upper Midwest seems a little quiet to me, you know. I think some of the areas that I've seen around the country, from between what I've read and what I've seen on YouTube videos, it looks like it's a little bit easier to catch a QSO, you know, in some areas of the country compared to here, but it's not impossible, certainly.
Well, my experience is from a couple years ago in Idaho, and I set up, I bought my arrow, got my handheld out, and first time out I had 2 QSOs. And part of it, I think, was because the way it works is you say AC7YZ DN13, and people are, you know, capturing grids as part of the activity there.
Right.
And DN13 is, you know, upper, well, in Idaho, and not many people had that.
Yeah.
So,
Yeah. And that's the thing about the Twin Cities. When you throw your grid out there like EN34 or whatever, they're like,
Yeah. Yeah, I've got that one. You know,
Yeah.
I want to talk to this other guy.
That's
So
very
they're
true.
going to answer up that guy. Or you try to call someone, and you know they're trying to work someone else. So it's kind of like a pileup. At least in Idaho, and part of it was that when the satellite was west of me, I had a ton of Californians. And when it was east of me, I had a ton of Texans.
Right.
And, you know, they kind of overwhelm everything.
Right. Right. Yeah.
But I did manage to get one guy in Massachusetts once when it went up over the Midwest. And I think, if I recall, he had, you know, this full-blown 1,000-watt system on rotators and, you know, and it worked real well for him.
Yeah. Not to cut you short, but I'm going to get the hook here. That's an arrow antenna, so you can see it. It's got a handle on it. It's got your coaxial connector. It basically has the diplexer built in. It breaks down, so you can put it in a backpack. They usually come with a little nylon sleeve, looks like a sling for arrows. They are made from aluminum arrow shafts. That's why one of the reasons they're called Arrow Antenna Company, but it's kind of cute. And, well, this will be included in the minutes or on the website, so I'm not going to blast through that. But as I said, there's some resources for some things out there, some interesting reading. AMSAT and the N2YO website are the top 2 for getting a bunch of general information in this subject matter area. So, good resources. Okay. Any questions?
Are there like spotting networks and all that, like you get an HF or
Yeah.
SCADs and that whole infrastructure, I guess?
Yeah, a little bit. You mean as far as like JT65 and stuff, where you can see who's active? Not just the satellite visibility, but also QSOs?
Yeah, I mean, just spotting networks.
Well, yeah. So that site I showed, from the standpoint of spotting the satellite or actually syncing up with the satellite pass, you know, there's a couple of those. But that's really the most comprehensive one. I don't know if there's anything yet that's like the JT65 or type of site where they're showing beaconing, you know, where there's a lot of beacons and then essentially you see the propagation, right? That would be nice, actually, but if all you're going to hear is blip, blip, blip beacons, that's not going to do you a lot of good either, you know, so.
The one thing that I found is sometimes satellites are down and you can waste a lot of time trying to connect to it. So there are some sites that kind of track, you know, I made a contact yesterday or whatever.
Yeah.
So
Yeah.
you can see, well, at least it's still working.
AMSAT has a table on their site that's supposed to show that, but it's archaic and it's been broken
Yeah.
for as long as I've been a ham operator. last couple of years it's been broken, and they've been trying to replace their website slowly, and hopefully they'll get that working again. But it showed exactly that for every I think it was half-hour time slot, how many QSOs were logged.
The other thing I want to add for operating that really helped me is that, I had my handheld, but I had a microphone connection. And that allowed me to be able to see the frequency I was dialing in and talk at the same time. And then I also hooked up some headphones because you have to turn your squelch off, so it's real noisy.
Right.
And the other part of it was I had a little Panasonic digital recorder, one of those little pocket things, and I recorded the whole pass because I don't know about you, but when there's 14 other call signs out there, I don't remember which one to talk to.
They're hard to pick out.
And
Yeah.
so, and if I did talk to someone and I talked to someone else, I forgot completely about the first one, even though I'm scribbling down, trying to do all that.
So the last
recorder
meeting,
really helped.
Roy had mentioned to me, so you're gonna demo some of this, and I thought about it, and I said, well, yeah, except I don't like the cold any more than anybody
Yeah.
else does, so. And, there's some coordination things that have to take place to do that with the past predictions and stuff for this particular location. So what I was thinking is maybe we'll do something, either I will or Roy and I will, for the summer, when we can just go outside for a few minutes and try to, get a QSO going.
We could talk to
Maybe
each
that-
other across the parking lot.
Maybe next month while we're here for most of the day.
No.
Yes, it's a
Field day.
fall.
Just put those two
Yeah,
guys on the
field
side with the
day.
TV camera and we can all watch them.
Yeah, field day would be good.
Yeah.
Yeah.
Well, we'll see what the temperature looks like. I might bring that.
44 below.
Remember one field day, they were trying to make a satellite contact, and whatever you do, the satellite's going at 5,000 miles an hour. Running across the field day site is not going to help you. Especially when there's guy wires.
That's the challenge.
Elevated radios.
Yeah, if I want to add to the Russ, the whole idea of amateur satellites is what got me into amateur radio. And, back years ago when the Phase 2 one was out is when I first got interested, but I could never pass the code. So I never actually got my license. But that one was on an orbit that went way out close to geocentric and then back again. So it was visible for hours during the day. And I thought, oh, this is great. And I never got to work it before it failed. But, when I got my license and I got things together, in just a few months, I had like 75 contacts. Again, because I was in Idaho, I think that had to be part of it. Yeah. Now, a lot of it was the same people.
Yeah, that's a valid point if you're ever going on vacation and take some gear with you. Because an early antenna and a handy talkie, which you might have anyway, is not a lot to carry. If you go to an odd grid, like the rovers do at weak signal, and throw out your signals in that your call sign in that grid that you're in, you may get quite a bit of quite a response to that. Certainly. But like I said, around here in the Twin Cities, it's a little harder. But
All right, well, thanks, Russ.
Do you have to be outside?